Today, we'll be talking about GIS application in our world today. You need to see our speaker. Our guest for today, Oyelami. Well, he's a self-motivated GIS analyst and he's in love with web map applications. He earned his Bachelor of Technology in Remote Sensing and GIS from the Federal University of Technology, Akure. And he also has 4 years of professional experience across the IT, utility, and telecoms. Worked in various companies on various projects, such as being a GIS field supervisor for asset mapping and customer enumeration projects, also in market qualification and survey projects. Some of the companies where he had worked are listed here: Polaris Digitech Limited, Keja Electric. I'll be inviting him now to talk to us about the evolution of GIS and then the practicality of it in our world today. Mr. Oyelami, you have the floor now.
Yeah, Tonya, thanks very much for that wonderful and brief introduction. And thanks to the TGH team for setting this up and for inviting me to talk on this. And I also want to thank you all for being here to listen to, what we have to discuss over here. So just give me some few seconds to try to share my screen and we can start. Yes, like Tonya said, my name is Akintoye Oyelami, and so when I got this topic from the TGH team, and in conjunction with GIS Day, I had numerous ideas in my head, because GIS application in our world today is so vast that we could go on and on to talk about it, and the time will not be enough. And coupled with the fact that it's also a GIS Day, I mean, it's a big thing. And I must say, sometimes I happen to talk very fast. If you see I'm probably talking very fast, or I'm using some terms that you're not well familiar with, do well to just put that in the chat box, and I'll be sure to probably reduce my pace or try to explain some of the terms I'm using. So let's dive into it. So who knows this powerful couple? I mean, anyone familiar with Esri, ESRI, would know of Jack Dangermond and Laura, which is his wife. And it won't be good for us to celebrate GIS Day without recognizing this powerful couple who has impacted GIS domain quite a lot. And for people like me, who got to know GIS through their software, which is ArcGIS Desktop, basically, would have thought that ArcGIS is the whole GIS. Well, you might be right, because they are like the influencers in the GIS domain. And I just thought that I would drop that in, just to refresh our memory. And also another notable person we should try to appreciate for bringing GIS to life is Roger Tomlinson, who happens also to be the father of GIS. Sadly, he passed away in 2013. And this guy's contribution to GIS is so numerous, and he actually named GIS and gave us what GIS is today. So anytime you get to use GIS, or you get to mention GIS or apply GIS wherever you're doing in your in your work, professionally or education wise, you should always give thanks to these people for their immense contribution to the GIS domain. So let's begin. So I felt we should just try to brush up our memory, to go from the basics of what GIS is built on to how it's being applied in the industry today and what it is today. So like every other domain, GIS also uses data. And data, it's a fact or characteristic of something of interest. Just the difference between GIS is that you have to understand the data you want to get and how you might want to use that data. So for us, we are not just getting data. We have to understand the type of data we want to use for the analysis we want to do. And I'll talk about that as we progress in this webinar. And of course, it makes sense why GIS is a geographic information system, because you use the system to derive insight from the data that we have. And for GIS, we just don't use any data per se. We make use of geographic, or what we know as spatial data. And spatial data is just basically a data that describes the geographic or spatial aspect of a phenomena. A phenomena can be probably a point, a line, depending on what we want to use it for. And so this is powerful aspect of GIS, because you're not just dealing with the data alone, with the attributes of the data. You're also dealing with the location attribute, so you can see the data where it is actually on head, or wherever your area of interest is. And geospatial technologies encompasses all other technologies that has that are geo-enabled. That means any technology that allows you to bring in a spatial data, that allows you to to acquire them probably through field activity or via the internet online, and that allows you to analyze that data, right? Allows you to manage, store, which is kind of very important attribute of GIS, because the ability to analyze that data without you being without you still having that raw data somewhere, and you can easily go back to the data to pull it out to derive some kind of whatever analysis you want to. It's not limited to just a particular aspect. And so geospatial technology gives you all this power. You can acquire the data, you can analyze it, store it somewhere, visualize it, manipulate, and try to derive some every insight you want to derive from there, depending on where you want to use it, right? So in GIS, you basically have two types of data types, and this has evolved over the years, but till today it's still the same data type, no matter how you are manipulating them or how you are getting them from. So for spatial data, is the data that already has its attributes, right? It could be a raster format for those in remote sensing, or that doing a kind of change analysis. It could be a vector format, which is just your points, your lines, or your polygon, depending. So these are the types of data we use in GIS. So no matter how you are getting the data or the source of the data, it's still going to fall within this category. And we also have the non-spatial data, thanks to the technologies we have now that you can. So spatial data, non-spatial data is just your columns and your rows and columns. You can, GIS now allows you to bring in non-spatial data, then you can join it to a spatial data, right? So it gives you that privilege to do that. And also you could also turn a non-spatial data that has a location attribute. It could be your XY coordinates, or it could be maybe a zip code, an address. So you could also geocode that, just giving a location attribute to a non-spatial data, so that you can actually see it on a GIS platform. Tonya, please, I would need you to just get through to me in case someone drops a chat, in the chat box, because I can't see the chat box at the moment. Thank you. So these are the data we work with in GIS. So like I said, these data types remain valid till today. And these are the the vector data I talked about, points, lines, and polygons, and you can overlay this to get whatever insights you want to get. And points can be building, can be whatever that has just that has a 0 dimension, and lines can be whatever. So all these are actually scale dependent. So a line can be a polygon in some aspect, and a polygon can be a line in some aspect, depending on the scale where you use it from. So these are some of the data types that allows us to make use of GIS and to apply them in our current world now. And most companies that are using GIS are usually using this vector data type to do their analysis, to derive insight from their data and all. And they could use the raster format as a kind of base map, to actually tell that, okay, this is just to do uh, a kind of reference point for this data to know, to understand, okay, it's actually where we said it is. And I must say this data type also, depends on the accuracy of whatever you're using to gather the data. And over to the right here, we have, the raster format, which can be in form of imagery or can be in form of band combination and all. And one of the importance of GIS now is that it allows you to move between these data types. You can convert from raster to vector, and you can convert from vector to raster through a process called rasterization or vectorization. So GIS has evolved from, the process of georeferencing, hard copy maps, for you to be able to use in a GIS platform, to the fact that you can actually take those pictures and convert it straight, either by running a script on them or by doing them manually. So what actually led to the GIS we know of today is arguably the emergence of geospatial web, which allows GIS to evolve from the standalone system that we know it to be. From initially you'd have to do your analysis, and if you want to share your data with someone else, you'd have to probably use a drive or a flash to take the data to put in another system, and then you extract it, and then it continues. But the emergence of geospatial web has allowed GIS to to be connected to several systems where you can easily get a data on the field, and in real time you can have it at the back end for people that want to analyze it. And it also allows you to share large number of data, and this is what companies are leveraging on today in applying GIS in whatever they do, because it's so connected to other platform, other system that can easily pull it off, and it just makes everything easier. So well, GeoWeb may not necessarily be considered a GIS, but it certainly draws upon the same concepts and ideas of geography, and may someday encompass a GIS. But most GIS we have now are web-based, whether you are performing the remote sensing analysis on the platform, or you are gathering your data in real time and analyzing this data. It's just, everything is just tied to the to the geospatial web. And like I said, web mapping, web service, social media, and cloud computing, and also crowdsourcing from different aspects of the world, where you create a kind of project, and people from different part of the world can input their data, and you have all this data in a single system where one person can analyze them. And also geotag, most pictures contains what we know as address, or however you can, or the location where the image are taken from. So the guys who are into programming, or who are into web mapping per se, can extract locations, addresses from pictures that are online. And also VGI, which is volunteer geographic information. Example is the open street map, for those that volunteer for an open street map. This is what you're doing. So these are the evolutions of GIS over the years, and this has helped GIS to be able to integrate to most of our businesses and other aspects of our life today. And also we have people that do web scraping and all. So broadly, we have three approaches to GIS. The application approach, which is where myself and some other people are falling, whereby you have what you're doing already, but you just need GIS to help you to better understand your data, or to better understand how you can serve your customer better, or to better understand how you can make informed decision, either on the go, or to present to stakeholders and all. So GIS has its application approach, and that's why you have someone in agricultural using GIS, someone in health using GIS, someone in utilities using GIS, and also because GIS can be applied to these various sectors, it makes it so dynamic, and everybody now gets to use a GIS in whatever they want to use it for. And we also have the the developer approach, which is people having some IT skills or people from computer science background can also use GIS to develop their own proprietary software that is pertaining to their type of business. So for the developer approach, you'd have to know some programming languages so that you can integrate GIS in whatever you're doing. You can fully develop your own GIS, separately, or you could leverage on some of the existing GIS software, like the Edge software. If you have enough money to buy some of their points, or you could use open source software also. And we have the science approach, which is for people in education, and that's why there's always an argument if GIS is a system or GIS or GI as science. So sometimes you see GI system, or sometimes you see GI science. Everything is just tied to whatever approach you want to use GIS for, right? So and of course, GIS is able to do this for things. You can use GIS to analyze either spatial concept or function or relationship. You can use GIS to build, which is the developer approach, programming and application development, web maps, desktop tools, and all. You can use GIS to visualize, which is the most common aspect of GIS, where people be like, okay, just want to show map and all. But GIS has evolved more than just the visual aspect. The visual aspect still plays a lot, yes, but that's not the only aspect of GIS that it is, but it's what people has come to know of GIS. But yeah, of course, geo visualization, which is also tied to the web mapping and geo report and some other things. You can also use it to create additional database design, linking of several databases together just to do whatever you want to do in the GIS interface, right? So these are the four basic ways GIS can be used in every organization. And how has GIS been used across businesses around the world? You have site selection. Probably you want to for people in businesses, you want to create a new company, or as in, let's even say people in the restaurant business, you want to know where best can you open a new site. So you'd have to know the competitors around your area, where you have your own shop, so that and you try to analyze the customer that are within that area. Would it be feasible for you to build a new structure, or a new to open a new shop in this area? So GIS can be used in that aspect also. No matter how small your business is, as long as you have the right tool, the right GIS platform, you can use it to make an informed decision. Resource inventory, land management, for taxation, parcel boundary extraction, building footprints, to know who owns what land, and how you can use that to tax people accordingly. And also another important aspect is demographic analysis. But people in human geography that wants to know how is the demography of this area, and how who are those here, their age limits, their everything about human that you want to know. You can also use GIS to analyze that. And network analysis, logistic, how what is the shortest way to get to your customer, that kind of stuff. And basically people that use Google Map a lot would have used an application of GIS. If you want to know, okay, Google Map, tell me how to get to this place, and Google will tell you that this is fastest route based on less traffic, or maybe the route length and all. So this application of GIS across businesses is so many that depending on where the type of business you find yourself, that will determine the aspect of GIS you are using. And that's why I decided not to put a definition of GIS here, because apart from the broad definition of GIS is just how you're applying it to your business. For example, someone in the logistics will tell you it's helping to know where my customers are. Right, that is the where. Someone in probably archaeology will tell you that GIS helping to know when these changes occur. Right, so it just depends on how you want to, or on the application of if you don't, then you're using GIS, right? So these are some of the aspects, and today we'll be focusing on just one aspect of this, which is the utility industry. And I think, yeah, so why are people using GIS? One, because it saves you costs, right? Logistics industry, it helps them to maximize their routes, right? To minimize their route rather, and it helps them to once they have the location of each of their customer, they can know how to plan their day. So in order not to, waste fuel, and also increases efficiency, you get to serve your customer better, and for better decision making, how can I best serve my customer, where my customer, how do I get these services to them. And also these are part of the reason why companies use GIS, and also it helps with better record keeping. You have all your data stored in one place that you can easily pull them out and see that, okay, this is changes that that has occurred over time, or this is the list of my customer, or these are the list of my assets. And also that's explains the managing geographically, and it helps you to know where your assets are, your asset being your company's infrastructure, where they are, how to best manage them, how close they are. It just helps you to understand their spatial distribution geographically, and this can also help to improve your business efficiency, right? So how is a typical electricity utility company in Nigeria using GIS? So in the distribution sector, I think at about 2017 or thereabouts, there was a kind of order by NERC for discos to account for their assets and their customer. So what they did was that they know they have some assets, scattered all over the place, including their customers and all. So they leverage on GIS through web map application to deploy forms, which is used to gather data, both attribute data, which is explaining the type of phenomena that is there, to map their poles, their transformers, and their customers. Now this helps them to bring all their assets into into GIS platform, so have an overview of all these their assets, to know, okay, this is our total area coverage, right? This is where our customers are. So it just helps to create boundary between them and other discos, and to understand where they are at the moment and where they need to expand to. So that is one application of GIS in the utility industry. But that is basic. That doesn't help them to save whatever. It just helps them to understand where their assets are and their coverage. So, but internally, they would use this to make some informed decision. For example, they know the total transformers they have per network. So I'm trying not to use some technical terms in electricity so that I don't I don't lose people here. So they try to use this to understand the total capacity per their network, or how they call it, per feeder, right? So they can know if that feeder is overloaded or not, right? And they can also use this to understand the state of their assets. Where do they need to erect new poles? Where do they need to change these poles, just to optimize their service delivery to the customer, right? So that's also an aspect where they are using GIS. And also GIS can be integrated with SCADA or with any other platform that helps you to automate the process. But I'm just talking basically on the I'm just talking on the basic application of GIS in electric utility industry, how they are using it. That is the technical aspect. And also they could also know if there's a fault somewhere. They could also use because they already have this asset in a GIS system, they can use it for easy navigation to where the asset is. So that saves them cost from just driving around and trying to know where the transformer, so to say, is. It's could also help them in their customer management, or probably in load shedding. Okay, we know that this particular phase is having a low voltage. Why is it having low voltage? Then can bring in customer data, and because this customer data is linked to each of the transformer and each of the feeder that they had, they can use this also to understand how they can better load shed that particular area. So that's also one aspect of GIS. And also, if they want to expand their network, they know the best way to the nearest transformer to connect a customer, right? So that's also one of the aspects. So this helps them to save costs, to increase their revenue generation, to also help them better serve their customer, right? So that's another aspect of GIS application in utility industry. It's very vast, but these are just some of the ways these guys are using GIS to improve their network and their service delivery. Um, Another aspect is the telecommunication industry, which is fiber optics. As we all know, fiber optics is kind of getting recognized in Nigeria, and that's like the new next. That's like the next horizon we have. So, but how are these guys using GIS, right, to stay informed about the markets they are coming into, right? So for fiber optics company, since they are just trying to integrate to come into the system, they have to understand the areas where they have to launch and the people they have to serve. So because unlike the utility industry, these guys has to know if the people in this area can actually afford the kind of broadband we want to give them in that area, right? I'm not just wasting resources by giving them a very high broadband, and then they are not able to meet up to the demand for us to get our profits. Because I mean, every company wants to make a profit, except for NGOs, right? So they have to understand this. So in order to do this, they also have to know the type of customer and where they are kind of clustered and how they can deploy their assets in that area. So it's a very simple but technical way. First is that how can we get our line to this area, right? So once you understand the right of way and the infrastructures we have to build along these corridors, right? Then who should we serve first? Is it the high paying customer, judging by their building types? Because so I think a message dropped on the group, but I'm unable to
Please,
check
Basil,
the
if you would like to drop anything, just make use of the chat box so that will not disturb the speaker from talking. Tickets. Make use of the chat box in case you need to say anything. Thank you.
All right, thank you, Tonya. So these guys would map out each of the building depending, because it's they believe that if you're staying in a very luxury house, right, that means you are living above poverty above the poverty line. So you'll be able to afford, the type of data and the type of internet broadband they are bringing out to your area. So, or for a rural area now, and your house is just kind of maybe a face-to-face that is not even well plastered. They know that you are not a potential customer for that kind of broadband they are bringing to your area. So, mapping out these customers using GIS technology helps them to bring, to have an overview of all the potential customers they are to serve, and also helps them to know the best way, the shortest route length that will save them, the fiber cables to get to that particular customer instead of just merry-go-rounding. So, GIS helps these guys to make a better decision on the best way to lay their cables, and the decision on on the type of broadband to give to that area, so that they won't have more resources for a population or a neighborhood that won't be able to pay for that kind of broadband they are bringing. And also for businesses, is it the business that can afford a B2B type of internet connection, or are you just a one-man shop, or that could just afford maybe a 1,000 subscription per month? So GIS also helps them to make that informed decision, right? So at the end of the day, they are serving the customers they are supposed to serve. There's no they are also getting the return on their investments. And of course, this can also be integrated with other platforms that helps them to know, okay, there's a fault in this area. The technical team, there's a kind of cut in this area. This is a map, either an interactive map or whatever they want to use this to navigate to the area. So that helps them to face the problem head on, and to help in resolving whatever faults that happened in that area. So these are some of how GIS is being used in this in our world today. And I would have gone deeper into this, but the time given, and this is just supposed to give an overview of what GIS is doing in our world today, how it has evolved from a standalone system from the time of georeferencing and digitizing to now to the application of web maps, of web maps to the businesses and to the industries today. So this is just a typical example of two separate industries making use of GIS. And of course, these two companies have something in common. They are making use of the vector data type, which is the point, the line, and probably the polygon for the building. So like I said, GIS has evolved, but it's still leveraging on the same data, right? And the attribute data is also there that explains what each entity means. This structure is this is what it means. This customer, this is the name of the customer. This is where they stay, and all of that thing. So GIS has really evolved from that state to where it is today. And someone in health sector will tell you a different thing. Someone in agriculture will tell you a different thing, and it just goes on and on. Yeah, so these are some of the ways GIS is being used in in our world today. Yeah, have a happy day. So Tonia.
Thank you so much, Mr. Kikoye. That was quite
Yes,
insightful. That
thank
was
you.
great. Well done. I believe David would have something to say, right? David, are you here?
Yeah, I'm here. But before I speak, I'd just like to ask if we have questions for our presenter, and we can just go ahead and ask our question or drop our question. We can do this for the next 5 minutes, then I just wrap up. Someone was raising his hand earlier, so if you have a question, you can just ask. You can feel free to unmute your mic and ask the question, and if not, you can also use the chat box. So let's do this like real quick, so we can move to the next question. All right. We'll drop a form. Antonia, kindly drop the form in the chat box. So you can still ask questions like later if you don't have like a question at heart right now. So you can always ask a question later, and you can always drop a question on our social media. So we would like to thank our presenter for the like really beautiful presentation he has like given to us today. And before we wrap, we would like to also inform you that for the plans of the call, we have some licenses we are trying to give out. So you might just be lucky enough to be one of the people that will be the Esri license. So the license covers for personal use, and you can actually Also, license for GIS Pro as well. Not just AppMap. So you give you license, and I think you'll be given about 100 credits to enjoy with. And also, before we wrap up, I think it would be nice to also inform us that we do this monthly. So we have like monthly webinars, and we have your emails now. So we'll be sending you links whenever we are going to have our next webinar next month. And also, we have a series coming up on LinkedIn and Twitter. We have a poll, and the poll was basically, like our presenter mentioned, GIS is like evolving and is moving rapidly. So he told us GIS is not just standalone system right now, or the traditional way whereby we do GIS and we like had to traditionally we had to like talking about sharing of or transferring data, how difficult it was. So he was trying to highlight some of the advancements in GIS. So just last week we posted on our social media and we had a poll, and the poll was basically to like um see other ways we do GIS. You also mentioned web GIS, right? Like other ways we do GIS, like outside our desktop, outside our system. So we're looking at starting a series on, because it's been actually if I just let me share my screen for a moment. So if I go to our YouTube channel, um right, so I believe you can all see my screen. This is what our YouTube channel looks like. And we have on our playlist, we have videos on machine learning, Python, remote sensing, and AppMap, and understanding what GIS is stuff. So we talked about like making people understand other stuff, and that was where we talked about doing something on GeoPandas. GeoPandas is a way to automate GIS tasks instead of using your software QGIS or AppMap. And we also talked about doing SQL. SQL is kind of very, very in vogue now, and it has been around for quite a number of time. So basically, it's just like trying to do GIS, but without using the GIS software. So probably using programming or using the software coding language. So we made a poll, and at the end of the poll, people really wanted to like, learn more about SQL. So very soon we'll be releasing like weekly videos like we used to on SQL. So it will be very nice for you to like do well to subscribe to our channel. I'll just leave a link um to the channel in the sorry, the channel in the chat box. You can like always um follow our channel, and also the Hub on all social media. It would be nice if you give us a follow. And finally, I would also like to talk about our website. So we just basically figured we couldn't, like, YouTube couldn't do everything we need to do, and we need to expand beyond YouTube. So in terms of posting blog articles, and also creating content and giving certifications out for this content and a whole lot more. So you could come to our website. You just have to Google the job.com. I'll just paste the link as well to the channel. So would appreciate it if you like go through the website and you explore about most of the content on the website are free, and you get certifications for this as well. So would also appreciate it if you go through the website and follow us on all our social media platforms. So Timothy also sent a quiz to the chat box. So would really appreciate it if you take your time to go through the quiz, and but we also appended a password to the quiz. So because we'll be like using this to get your feedback, and also from the people that you we'll be able to like select those will be giving the license. And I must mention again that license is limited. So we currently have 18 people on the call, and we have 10 licenses to give out. So I mean, I'll just appreciate it if you're not offended if you don't get the license. We are basically running a random function to select people randomly to get the license. That will be, I think, all from my end now. And Antonia, Babatunde, or our presenter won't add anything before we say our goodbyes. I think that will be a good time.